The following is a production of Woods Hole Oceanographic Institution.
The deep Gulf of Mexico is surprisingly understudied for being so close to the United States and so important to our economic base. And so the Bureau of Ocean Energy Management had been thinking for several years that we needed to make some new observations of currents in the deep Gulf of Mexico. The Deepwater Horizon oil spill happened. And that made it even more obvious how little we knew about where oil would spread in the Gulf of Mexico, especially below the surface. There has been quite a bit of study of one major current in the Gulf of Mexico. It forms a big loop, and that's why it's called the loop current. Sometimes those loops break off to form quite large eddies or swirling masses of warm water that are maybe 100 or 200 kilometers in diameter. And just like the loop current itself, these eddies reach very deep into the water column. We need to be able to measure those currents down there. They will affect how a deep oil spill might spread, and they will also affect how benthic organisms are transported around in the Gulf of Mexico. So it's not enough to just look out on the surface of the ocean. To measure the ocean currents below the surface, we use a type of subsurface drifter. It's called a Rafos float. The Rafos floats that we are using are about 6 feet long, and they are in glass tubes. They sort of look like what you might imagine a thermometer for an elephant might look like. We very carefully measure their volume and their weight so that they will sink to a specific depth in the Gulf of Mexico and then drift around horizontally at that depth. While the floats are drifting, they are tracked underwater using an array of moored sound beacons.
We spread the sound sources out over many thousand kilometers so that the floats, no matter where they happen to go, should be able to hear at least two of the sources at all time. And that allows the scientists to track them and plot the positions using triangulation.
The float actually listens for these sound signals 3 times per day, and then at the end of 2 years, each float automatically pops up to the surface and transmits the data it's collected about these sound signals to a satellite.
You do not get your data back until the end of mission, which can be up to 2 years. So I know scientists are probably chewing their fingernails, wondering what's going on and will the float surface and did it hear everything okay?
So far we've deployed 180 Rafos floats over 9 cruises over 3 years. In the Eastern Gulf, there's a lot of eddy activity. In the Western Gulf, it looks very different. It's sort of like if you were to describe the Gulf as a bathtub. You've got one side of your bathtub, all the water swirling around in the center of it in these little eddies, and on the other side of the bathtub, the water is forming a boundary current, which hugs the wall of the Gulf, which is sort of like your bathtub, starting in the middle of the north wall and coming around the west, around the Bay of Campeche. The boundary current rounds the Campeche Bank, and instead of staying along the Campeche Bank through the southern Gulf, through the entire Gulf, and keeping with the boundary or the wall of the bathtub, it appears to separate, or the floats show it separating and moving into the central Gulf. This appears to be a entirely subsurface, sort of deep pathway, a deep conduit or highway or road for getting water off the boundary and into the Gulf, which we wouldn't have known about without using this type of instrument. I like to go mountain climbing a lot. I like to look at topography, maps of topography, and then go hiking along everything. The floats are similar in that you can sort of pretend you're in the deep ocean following along the mountain ridges or along the the cliff edges. It's like being an armchair traveler into the deep ocean. I get to find out the paths. It's sort of like finding out the hidden underwater pathways that are in the ocean.
To learn more about Woods Hole Oceanographic Institution, visit us on the web at www.whoi.edu.